All right, y'all. I wanted to return to that last problem we were working at the end of class today, just to give you an update on it. So I did rework it. A note to start with is that, so I am oversimplifying this, and really we shouldn't be talking about the H2SO4. I just wanted to kind of show the point with that you don't need to worry about it because it's a strong acid. But really, we should be using HSO4 minus from SO4 minus and H plus. Has a different pKsp of only 1.9. So this one you would have to deal with. I'm going to ignore that here, so it's not going to be a real solution. Just to show you how you would do this and get a reasonable solution. Okay, so we did do this part in class. We got the KSP for the gypsum calcium sulfate dihydrate, and we figured out concentration of calcium 2 plus in the solution. So we're going to worry about it as a weak base. So what I originally tried to do in class is to just look at the Kb equation here and this equilibrium expression for a base. But I think what we need to do is we need to switch it over, because you can turn it into a Ka by saying, zoom in on that part a little bit, by saying Kw divided by Kb, and I get this for a Ka value. So what I'm going to do is I'm going to rewrite Ca2 plus instead of the base version that I had up here. Now I'm going to say Ca2 plus 2H2O. And that's going to be in equilibrium with CaOH2. But those OHs came off of these two water molecules, leaving these two H pluses. So basically I've rewritten a base dissociation equilibrium as an acid dissociation equilibrium, because this is going to drive into the into the acid side, into the acidic, because it's a weak base. All right, so when we do that, our starting concentration, which we got up here from KSP, so 5e negative 3, minus X, because some X part of that is going to react with the water to form the calcium hydroxide. All right, so that's my minus X. And obviously I get X. It looks like that's a 2X, but it's not. That's on the below there. So it's X, and then here's the 2X. So you're going to gain 2 hydrogens from that. So 2X, 1e negative 7. I didn't end up needing that, but I put it just to make sure. Plus 2X. So 1e negative 7 plus 2X is my expression. Here's my Ka expression, 2.69e negative 12. X for the calcium hydroxide. The H plus expression does need to be squared because of the coefficient of 2 on it. Divide by 5e negative 3 minus X. I put that in my solver, and I did end up with a rational answer this time. X equals 1.5e negative 5. Remember that your hydronium concentration here is 1e negative 7 plus 2X right here. And that's 3.01e negative 5. The actual original 1e negative 7 doesn't even matter. It's way out a couple of decimal places even further, so you don't have to worry about it. So your pH ends up being 4.521, and this is reasonable. I think we're going to go with that for now. Remember my note earlier that it's not a real solution, because we should be considering other species like HSO4 minus instead. So this would really be a more complex problem than I would want y'all to work. Even the way it is here is more complex than I'm going to give you on the exam, so don't worry about this. I'm going to give you a KSP that you're going to have to calculate a pH from, but I'm going to make sure is an easier one than this. And if you can follow this, you're all the way good on it. And if you need a little coaching on this one, since it was the last thing we did, I think it'll be a good thing for us to do on Monday. All right, see you on Monday.